Okay, well now I'd like to show you the um, software that runs the spectrometer. So hang on for a moment and we'll get started. Okay, let's go ahead. So the first thing to do is to start the program Kestrel Spec if it isn't already running. There it goes. This is the program that controls the CCD camera. And we can just say yes to any dialog box. And there we go. It opens a window. And we don't need to do anything here except the following. We're going to go to Set. We're going to turn on Auto Background Subtraction, either one, Dynamic Background Image before. What this will do is when the CCD camera runs, it will take a dark image before it takes the sample image. I'm going to minimize this window now. The second thing we'd like to do is to start a LabVIEW program. It will be this one called Spectrometer 300i. It'll just take a second to come up. Okay, here, I think I'll pause while this starts. Okay, well now it's ready. This is the program that runs the spectrometer. And it's straightforward. Over here, we set things up. We set up the center wavelength for our spectrum. Right now, it's set to 520 nanometers. We could set it in nanometers, or we could set it in wave numbers, the frequency unit, or in electron volts. But right now, we'll leave it at nanometers. Okay, here's the exposure time. Let's set it to 0.1 seconds. We're going to do one exposure, but we could set this to a larger number to average over spectra if we wanted. Okay, and then we'll leave the grading set at 1. And now we're ready to go. To run the LabVIEW program, we hit this arrow, and off it goes. This actually calls the other program to take data with the CCD camera, and then it imports that data into LabVIEW, and then it calculates the wavelength from the position on the grading. And there we're done. In this case, I'm not going to save the data. And you can see what this looks like. We see nothing here. And then starting at about 540 nanometers, we can see light. And this light that we see is fluorescence from the card, okay? The white card that's being excited with the laser radiation. And that's about it, about all that we need to see here. I just wanted to show you how that works. Here, if we set this to a longer time, let's say 0.4 seconds, we can run it again. Notice the height here, about almost 4 times 10 to the 5. Off it goes. Now it's done. We won't save that. It's a similar height now because this is actually showing you counts per second. Oh, one more thing. What happens if we change this number? Let's make it 570. Now it will rotate the diffraction grading to move the spectrum in this window. There we are. And we can get a better idea of what the fluorescence looks like. By the way, the cutoff currently on the short wavelength side is actually due to the edge filter in the system, okay? We don't really know if this is cutting off. The laser wavelength is at about 532 nanometers, but it's almost completely blocked out by the filters, so we don't see it in this spectrum. All right, that's how it works. If we had saved the data, it would produce a tab-delimited ASCII file that we can open with Excel or Kaleidograph or some other data program. Okay, I think we'll stop here.